Good afternoon, everybody. It's good to see the Hardcore Jones seminar attendees here on a snowy day like this. Today, our speaker is Ron Lasky, who is currently an instructional professor at Dartmouth and a senior technologist at Indium Corporation. He has over 30 years experience in electronic and optoelectronic packaging and assembly, among other places at IBM, Universal Instruments, and Cookson Electronics. He has authored or edited 4 books on electronics and optoelectronics and numerous technical papers, and authored, among other things, articles for Scientific American. He also holds numerous patents and is the developer of electronic assembly software relating to cost estimating, line balancing, and process optimization. He's also the director of Dartmouth's Six Sigma program. Ron has 4 earned degrees, including a PhD from Cornell University in material science, and he's also a licensed professional engineer. Out of courtesy for our speaker, please, if you would, refrain to use laptops. Thank you. Ron?
Thank you, and thank you also for coming out on this kind of tough day. So what I'm going to talk about is electronics and whether we're experiencing an evolution or revolution. And I have to kind of quantify my background or qualify it because it's a pretty broad topic, and I am going to be talking about bandwidth and some things like that that I'm not as much an expert in as I am electronic assembly and more the hardware side of it. But perhaps we can generate some discussion for at the end. So, and I'd also like to acknowledge I work with Indium Corporation. I have a blog, and they sponsor that, and so a lot of what I've learned in writing the blog is a material for this presentation. Also, there are people that study this type of topic that I'm discussing and have consultancies, and Prismark Corporation is probably, in my Prismark Partners, in my opinion, is the best around. And they publish a yearly book called the Electronics Industry Report. I have all of them since they started publishing them in 1997. And it's interesting that one of our own, I think I got the year right, Brian Swiggett, I think he was 79, may have been 80. And he is, I think, the senior partner of Prismark Partners. And I know a few of the students have interviewed with him this year. So the question I'm going to be asking is, electronics in the last 25 years, has it been typified by constant revolutions, or is it really more like an evolution? But before we get into that, I'd like to look a little bit at the industry. I know most of us are technologists, and so I thought you might appreciate the size of the industry and a little bit of its how it plays out across the world. It is almost certainly the highest value add industry in the world. And what I mean by that is if you take a look at your laptop, the raw materials in it are in the neighborhood probably in value of something like $20. And so the laptop is worth, you know, in a neighborhood of $1,000 or more. And so that's a very high value add. I remember when I was a young guy, some people would estimate how much an automobile would cost, say in the 1970s, by, you know, weighing the steel. And then you'd put a little bit of an adder on that for the assembly and the profit, and you could estimate about how much a car would cost. And so that's not at all true with electronics. It is the largest industry in the world, and electronics people made a pretty big deal about this, and they debate a little bit when this happened, but it's right around 1999. It went over $1 trillion and surpassed the automobile industry. However, that's probably not really true. The biggest industry in the world is really food, and I had a struggle to find that number. The reason why it's probably not considered so much an industry, an awful lot of the food is consumed directly by the people that produce it. I'm also going to a little bit look at the, well, and electronics is clearly a world industry, but also a little bit look at the what seems to be a mantra in the United States these days. I know we have pretty much an international community here, but a lot of people wring their hands about the fact that we in the United States are not competitive anymore, and so on and so forth. And I can be sympathetic to a lot of that, and I'll talk a little bit about that, but hopefully we can examine a little bit of that here quickly. This is from Prismark, and this is the electronics world production. And there are probably some aspects of this that would surprise some people. One would be that the Americas, which is the United States and Canada, Mexico, and mostly Brazil, will produce or did produce in 2008 about $420 billion worth of electronics. Something like probably 90%-ish of that is in the United States because we're the dominant force. So this perception that we're no longer in electronics is not really true. These are some of the major companies, HP, Dell, IBM, and you can see the Motorola, Cisco. The thing that probably wouldn't surprise anybody is that an awful lot of it is being done in Asia. And when you look at this is quoting what 2008 was and projecting what 2013 will be, you see that China is where the growth will be, whereas the Americas have a very small growth rate, and Japan actually a negative growth rate. And of course, a lot of this growth is in China, but you can't neglect what the four tigers, Hong Kong, Singapore, South Korea, and Taiwan, because there's certainly a tremendous amount of electronics produced in especially both South Korea and Taiwan. This is just another little look at it, and it gives you a flavor, too, of in time the different breakdowns of the electronic equipment. You see when we're talking in, this is 1982, about 50% was in computers and communication, and when we go up to 2013, it's a little bit more than that. You also see that the amount in consumer electronics has gone down a little bit, and pretty much stabilized. But that can be a little deceiving because the price of all of these things has dropped so tremendously that the actual quantity of electronics that you have, it may be even increasing. And you see again, the Americas still even projected out to 2020 is about a little bit more than a quarter of the world's production. This is electronics in the Americas. And probably a little thought wouldn't be too surprising. We have computer and office and communications, but probably a lot of the communications is more infrastructure than it would be cell phones. So it's more like base stations and that sort of thing. And typically, the electronics in North America is going to be higher value-add electronics, something where there's more money to be made. And especially in the industrial and medical control part and the military. And you see we have just a small amount of the consumer. When you compare us to Asia, the rest of the world, they have a tremendous amount of communications and computer, but this is probably different. A lot of cell phone handsets here, and the computer is probably more personal computer, where in the Americas it could be a lot of mainframes and computers that aren't necessarily for personal use. You see the consumer is a little, quite a bit higher than it would be in the Americas, a lot less in the military and the industrial and medical electronics.
What is consumer electronics?
It would be something like a DVD player, a television set, and there were many people, this is something I've been studying probably for more than 20 years. Back even when I was in IBM, we used to talk about this, and somebody once said, Americans invented many things that are now no longer at all made in the United States, like televisions and maybe maybe not DVD players, but when VCRs were the big deal. But one of the things about it that you have to remember is there isn't much money to make in a lot of this. And I think that actually is my next slide. Yeah, this is, I teach Engines 1, the technology of everyday things, and one of the things the students do for their end-of-term project is they actually do a teardown analysis of an electronics, it doesn't have to be an electronics product, but it usually is, and they have to describe how it works and put it back together, and hopefully it still works. This is a DVD player that you could buy at Walmart, and it costs about $35. And even as much as I do this, I still am stunned that it's possible to produce all of this, deliver it to the United States, and put it into your hands for $35. That means that this was, if it was made in Asia, it probably had to be made for less than 15. And so, for the people that wring their hands about the United States losing this business, I have two comments to make. Why would you want this business? Because there's no money in it. But in a sense, it's a blessing to us because it raises our standard of living, that we can buy something like this that if it had to be made here would probably cost $200. by the way, the students that do this, it's really fun to watch them give their presentation, because some that come to this class, when they took the first day of class, did not know what a Phillips head screwdriver is. And they do this teardown analysis and discuss how the parts work and everything. It's neat to watch them do it. I just thought I'd sort of close up the world of electronics manufacturing by talking about an area that probably is not thought that much of as electronic assembly area. And to be honest, it in a sense, 50 billion is only the whole world is something like 1,400 billion. So it is a small amount. But the Eastern European countries in the last, say, decade have had sort of a renaissance in that they are manufacturing things like electronics, and because the labor rate there is so much lower than it is in the rest of the EU, they can actually do it quite competitively. I'm sure this isn't true today, but it wasn't too many years ago that the total cost of producing something in Bulgaria was less than it was in some Asian countries because of, especially if you're a European, the transportation costs were less. So this is an electronic system, and this is not the motherboard necessarily for this. Obviously, it wouldn't fit in there. Well, that's probably not even the motherboard. The motherboard's board's probably behind the screen. But in taking some product like a $1,000 personal computer, if you look at the breakdown of it, as you can imagine, the integrated circuits are the greatest amount of value. And the one integrated circuit that commands the most, of course, is the microprocessor, usually made by Intel or AMD. But there are a lot of other little things we have to pay for. Connectors are about 3% of the 1,000 or $30. And they're little tiny capacitors and resistors that are sprinkled all through here. And if you're actually the person that assembles these, it's something you have to spend your most time worrying about, because the part count is mostly these little tiny resistors and capacitors. And the smallest size now is 5/1000ths of an inch by 10/1000ths of an inch. And they're each individually assembled with a robot. And so they end up being about $40. The printed wiring board in the industry that's called substrates is about the same. The housing and I/O is about 160 of it. Assembling it and testing it is about 14%. Business term sales, general, and administration and profit is about 16%. Getting it to you is about 14%. And then there really isn't much left for R&D for the people that make personal computers, a little 2%. But that doesn't count Intel. Their R&D would be part of this, the 27% for the integrated circuits. So the entire chain to make electronics is really unbelievable in its breadth, because you're essentially starting with oil, sand, copper, a few other metals, and you're producing, and silicon, and or sand, and you're producing everything. And so if you look at the end result of about $1.4 trillion and go backwards, starting with raw materials, it's about 33 billion, and then making it into electronic materials, taking the copper ore and making it into copper, and the silicon into silicon wafer. Most people argue the folks that are making the most money in this chain is the people that take the electronic materials and make it into components, especially the people that make microprocessors. So this would be the integrated circuits, but also little discrete devices, like even almost any electronics you buy, even if it seems like it would only have integrated circuits, will have some individual transistors and diodes and the like. Maybe not your cell phone, but your laptop probably would. And then assembling this all brings the value up to about 940 billion, and then sending it out into the world. And this is the breakdown in the major areas. So you can see that people like Prismark that study this have a lot of different aspects to study. Just sort of finishing on the economic part of this, talking about America as viewed by some as the economic basket case. And there is a lot of concern in the electronics industry here living in the United States and working with a lot of people from the United States that used to work in Motorola when they manufactured all of their cell phones up until about 2000, and now manufacture almost none of them, although they still have engineers develop the processes to assemble the cell phones and then send them to Mexico or China. But still, we already saw that the U.S. still has a lot of the more high value add electronics, which is the more desirable medical, industrial, auto, military. But even if you're looking at the GDP, This is GBP, and we all see the little hiccup in 2008 there. The United States is dominant. And if you think about a place to live, it can't be that bad to live in a country that produces more wheat than any other country in the world and more corn than all of the other countries in the world combined, and we still got Apple Computer. So I mean, there are reasons to be optimistic. I don't want to sound too rosy on this, because I think concern with our manufacturing competitiveness and all this is a legitimate concern. So let's talk a little bit about electronic products. And I'm hoping at the end we'll have enough time. Alex, I have till 4:30. Is that about right? Yeah. Yes. Okay. I actually have the slides, a teardown analysis, actually taking my droid and taking it all apart and cutting through the circuits and seeing how densely it's packaged and all that, compared to an iPhone. And so I hope we have enough time to do that. But if you go to about 50 years ago, the main things that drove electronics were its function and cost. And the 50s pocket transistor radio, there probably aren't too many of us here that can remember this, but right around when the transistor radio came out of this size, it was a big breakthrough. And we think that the iPod is the first, the major portable music device, but this actually had the capability of, you could plug a little primitive earplug into it and listen to music. And there was a song that came out in 1961 called Transistor Sister. And you can date yourself if you remember that. But one of the unbelievable aspects of this period of time is you expected to keep the electronics for a long time. My parents had something like this they got when they were married in 1941 and kept it until 1970 and gave it to a collector. I think they should have ended up selling it to a collector, because it's probably worth quite a bit. We've probably all seen this picture of the ENIAC computer, and used 200,000 watts of power. That's going to be enough to heat 20 homes. And another example of the longevity of computers then, it was built in 1945 and it was used to 1955. So your laptop is about 20,000 to 100,000 times more powerful. That doesn't surprise us. But one of the big issues of this, and for those of us old enough to remember when vacuum tubes were common for television sets, was if you assume the average vacuum tube has a life of about 1 year and do a little 8th grade statistics, you'll see that the thing is breaking down every couple of hours. And it's not a joke. They had to have teams of people and had to have the circuits designed so that they could pop it out and pop another one in that would have its vacuum tubes, because it would a 2 or 3 hour run might be a good day. So here's a little bit of the evolution. In World War II, the radio man was very important. Communications is very important in combat. And when the Germans were victorious early in World War II, people that study that say one of the critical things is they could communicate amongst their tanks and airplanes, and the French and the other people they were fighting against couldn't. So a radio man in World War II was often the target of snipers. And in the beginning of World War II, he had to carry this heavy radio pack and everything, and it was like 30 pounds. By the end of the war and into the Korean War, Motorola had developed, this is circa 1950, a radio that was more portable and had about 5 to 10 circuits. This 1965 transistor radio had about 10 to 20, and an iPhone 4 has in the neighborhood of something like 500 million. It's incomprehensibly more complex. However, that we're asking the question, are the products we have today really a revolution or an evolution? And most people consider this the first portable cell phone. Actually, the first cell phones go back to maybe even before 1970. They were in cars and very expensive. This is the first portable one. And today we look at this and laugh. It seems so comical. Here was our friend Michael Douglas from the first movie Wall Street with a phone. But at the time, that was a status symbol. It cost $4,000 and it cost like $2 a minute to use. If you see the new movie, it's kind of comical when he gets out of jail. The guard gives him all the stuff and then says, and one cell phone, and plops that on there. It's kind of comical. So, you could argue at one level that we've really just had an evolution. This is a cell phone and this is a cell phone. And of course, I'm going to argue later that that's way too simplistic. But even something like a digital camera, we tend to think of them as, relatively recent inventions. Probably not many of us had one much before maybe the late 90s. But one of the first commercial ones was in 1998. It's only 0.4 megapixels, and now we're up to about 14, and you can get these at amazingly low prices, like $150. Personal music, well, we already talked about a transistor radio really would allow you to listen to music. Of course, it couldn't be selective. But the Walkman is clearly a very significant invention. The people that tracked this, I can't remember the group, they did a survey of people, what is your favorite electronic product from the 1980s? And the Walkman was won by like 3 times the one that was in second place. And if you really look at the storage capability for this, it's not too bad. It's something like, if you had a 120-minute tape, it'd be something that's in the neighborhood of, something like probably 30 songs, so maybe something like 200 megabytes of storage, data storage. And of course, we can do, I'm going to show Apple so many times, I thought it was only fair to give the competition a little picture here. Today, Zen, you can go up to 16, 32 gigs, so certainly a lot more. But when this first came out with the limited storage capacity, it wasn't really overwhelmingly different than a Walkman as far as the amount of songs you could have on it. Video. I showed you the DVD player for $35. It still amazes me that can be done. And I think many of us in the room can remember when that really was the price for a VCR. But of course, you could argue that this is a strong evolution from this device. Well, so you're thinking, well, he's probably not going to be able to come up with a laptop that's almost 25 years old, but yeah, you can. Here's a 1985 laptop. It had, the biggest kick I got out of a baud is bits per second. 300 bits per second was the modem for this to communicate over some sort of over a telephone line. It could take floppy disks, and if you do the calculations and everything, your laptop today is 10,000 times faster, but it has 1,000,000 times more storage capacity if you've got a terabyte, which is getting in the neighborhood of what we have today. Oh, and also the clock speed, something like 4 megahertz versus today we have more like 2 gigahertz. So in conclusion, electronics is only a revolution. Thank you for your attendance. Well, that's not really where we're going to end, because what of course the big difference is, it's not an evolution in the individual products, or not a revolution in the individual products, but it's clearly a revolution in the way that they're used and connected together. That's where the true revolution is. And it's been delivered, in my opinion, by at least 3 things. See, I get kind of a way out if somebody can think of a 4th and a 5th. I say at least 3. Very cheap computation speed. That stands for million instructions per second. Very cheap memory, and interconnect and connectivity. And this is really what does a lot of it today. And this is where I'm going to say a little later that I think more needs to be done. Let's talk about cheap calculation speed, million instructions per second. Probably all of you have seen Moore's Law, where Gordon Moore said the number of transistors or circuits on an integrated circuit, circuit doubles about every 18 months to 2 years, and it's been pretty faithfully true. We're at the point where we're getting close to 2 billion transistors on an integrated circuit. But as important in that as that is, it's also the cost of all of this. And I don't think I've seen this plotted before, so I hunted around a little bit, and I did the cost of 1,000,000 instructions per second. Now, I haven't shown this chart yet, but your laptop is probably in the 2 to 10 billion instructions per second. In about I remember when I was in IBM, I was much younger lad, and I was working on a team. A mainframe computer in 1981, 1,000,000 instructions per second cost $64,000. $64,000. And you can see in time this has gone down to the place where 1,000,000 instructions per second now is something like 5 cents. And it's just amazing. And the interesting thing, and probably not too surprising because they're tied together, this rate, as the circuits are doubling, this cost is halving at about the same rate. One of the things I forgot I wanted to mention, this is actually not from my childhood. I got this from my kids in like the early 80s. It's a little owl, and it's a radio. It has 6 circuits in it, 6 circuits, and it still works. You can. The only thing I found out, I didn't know this until I moved here. We don't have radio stations. Is it just me that seems to think that's the case? So if we were to have a device that had circuits in this form factor, where we have 6 circuits in this area, and we wanted our device to be up here on this chart, the size of our device, this is not a joke, would be 200 miles by 200 miles. That's how big you'd have to have something if you had individual transistors to compete with the type of device we have today. And it just occurred to me, one of the issues, by the way, with that would be the speed of light is too slow. For those kind of distances, at the clock speeds we have, you know, everything would be waiting for everything else. So cost of MIP per year. This is another chart from Prismark, and this is a Texas Instruments integrated circuit, and we're looking at essentially the same function over time, and the size of the wafer that this was made on, it started at 150 millimeters, which is 6 inches. So it was a wafer like this. There were multiple of these die. They could get 310 die per wafer. When they say the process, that means the width of a line that connects, an interconnection line, was 500 nanometers. And so as you go out in time, you see the width of the line comes down. So this is 0.1 micron if you think better in microns. So this is, or 0.5 micron, 0.5 microns. So as you go out in time, the width of the line becomes thinner and thinner and thinner, meaning you can pack more things together. And so we're finally down to the type of technology of today in the 45 nanometer range. But also, the wafer size is getting bigger. And so instead of just 310 wafers, 310 circuits on a wafer, you can get 46,500. And this is a lot of the tremendous cost reduction that goes on. But some of the issues of these line widths is this is about 450 atoms in diameter. And so as time goes on, there will be reasons that this will become more and more challenging. Although 30 years ago, people said we'd never get here, and 25 years ago, they said we'd never be here. So we seem to always have developed a way to make things finer and finer. But one of the things that's occurring right now that helps this is people are learning how to stack die on top of each other in 3D die technology. But so what this boils down to, when you make things this small, and this is actually understated, a line width is in the neighborhood of a size of a virus. And a transistor is probably more like a fourth to a tenth this size. And one of the things that this has developed is an entire industry in clean rooms. You cannot make these things unless you have unbelievably a clean environment. Okay, so this is, I've never seen anybody plot this chart. I think it's probably presumptuous of me to think this might be known as Lasky's rule eventually, or Lasky's law. But the cost of solid-state memory has also decreased. And it just amazed me that on a log scale it ended up being so almost perfectly linear. Again, it's a little more than a 2-year cycle that the cost is halved. A little less than that, I mean. It's about every 20 months the cost is halved. In 1970, a meg of memory was $1 million. $1 million. And as you go on in time, we've had a few hiccups where occasionally there are little spurts of time when sometimes it'll go up in price because there's so much demand, there is enough demand for production. I remember in 1985, it was something like in the neighborhood of $50, and you see it's gone down to right now it's in the neighborhood of 5 cents. So that makes a lot of things possible that were no longer, in the past were not. If we take a look at things that we commonly use in our everyday life, a book is about a meg of memory. A piece of music is about 5. Obviously, it's going to depend on the size. A photo is about 1 meg, and it's going to, again, depend on how many pixels. A DVD movie is about 4,000 meg, and a high D movie is about 25,000. And one of the interesting things is these numbers won't change dramatically in time. I mean, we've done it with a movie. We want more resolution in the movie, so we've taken it up. But especially a book will probably continue to be about a meg. So as memory gets cheaper and cheaper and cheaper, there are just more and more things we can do. One of the things, though, and this is something I study a little bit for Engines 1, is, and it may be because I'm older, but I actually purchased a Blu-ray system, and I got some videos where you get a DVD and a Blu-ray, and I can't tell the difference. I can't tell the difference. Now, maybe I'm not saying there isn't. I can't tell the difference. Maybe it's old eyes and old ears. Well, one of the things that some people predicted quite a while ago is that solid-state memory would completely replace hard drives. And it hasn't happened, and it probably won't for a while, just because the price differential is so tremendous. This is the cost of hard drives. And the people just continue to find more uses for having a lot of things stored. And so clearly we have some computers where they have just a solid-state drive. But what people are thinking now in the short term is that people that are really into saving things and wanting backup and everything might have solid-state drives on their laptops, but then would have a hard drive someplace that they go and do a backup with on a regular basis. So probably we'll have hard drives for a while. But again, it's a really tough business to make money, hard drives. So I'm going to talk a little bit about communications technology, and some of us may have hadn't had this perspective, and I hope it's a little enlightening, but it's hard to miss the Facebook and Twitter, the effects of today. But my understanding is that people that study this will tell you that the Protestant Reformation started, I think the date is 1517, October 13th, when Martin Luther posted his 95 Theses on the door at Württemberg. And you tend to put a lot of studying into Martin Luther, and I'm not trying to take anything away from him. But 100 years before him, John Huss had tried to do the same thing. And there were other efforts in France. I think it was the Huguenots that tried to do similar things about 100 years before, and they never took off. And a lot of people believe that one of the reasons that it did for Martin Luther was because of the printing press. His 95 Theses were very quickly printed and were passed out to all of the German princes that were tired of having all of their money go to Rome. And so it was a little easy to get them convinced that they should be as upset as Martin Luther was about the excesses of the Catholic Church. And so that's an example of a communication tool aiding some significant event in history. Another one, World War II, when the Germans conquered countries in Europe, one of the first things they did is made sure nobody had a radio. I think you could actually be executed for having a radio in the lands occupied by the Third Reich in World War II, and even a printing press, because they didn't want people finding out what the truth was or communicating. Others believe that one of the reasons the Berlin Wall fell in the 89 era was because of faxes and the early email, the ability to communicate, the ability to tell people, let's come to the wall at such and such a time and chant, tear down this wall, that type of thing. But what has happened in the last just couple of weeks, almost all analysts are crediting Facebook and Twitter. The ability to have a communication technology that's very, very difficult for dictators to shut down. And so I'm going to be talking about communication, and I just think it's interesting to see how important it is in great events in history and right literally as we're standing here. So what I'm going to argue is all of these amazing things that I've talked about, our connectivity capability is not growing anywhere near as fast, and we're not complaining enough about it. Because it's almost in some respects not even changing, or even going backwards. Well, here's some of the early issues. When the telephone first came out, people actually, if I wanted to talk to Mark, I would have it's really important we communicate on statistics and stuff, and we would have a direct line between his house and my house. And I'd have one between my house and, maybe my parents or whatever. And finally, there were too many of these lines, so the exchange was developed where you would connect to the exchange and they could connect you to the person that you wanted to talk to. So it actually made this scene go to this scene in a few years. Well, modern communication a lot of it is done by optoelectronic technology, and it's something that I work quite a bit in. It's actually how I got to know folks at Dartmouth, because in the early to mid-90s, I worked with Ulf Osterberg on some of this when I was at IBM, and that's how I got to know him in Dartmouth. So the simple way it works is, so here's the grandmother. She's in Boston, and her daughter's doing an LSA, or not her daughter, her granddaughter's doing an LSA in Boston, in Paris. And so Granny speaks into a microphone. It creates an analog signal. An analog to digital converter converts that into a digital signal. And then Granny has to share that telephone line with 200,000 other people. And so a tag is, her voice is sampled quite frequently, and a little tag is put on each bit of information that is Granny, and it is multiplexed with the 200,000 other calls. These are ones and zeros. They're electronic, and they drive a laser. This is a 1 and this is a 0. Those ones and zeros go underneath the ocean. About every 20 miles, the signal, there's some attenuation in the fiber. The signal has to be boosted, and this is done underneath the ocean, which I think is amazing, a feat that was first done by AT&T. It comes out in Europe. It's an optical signal. That light is focused on a little detector that turns it back into ones and zeros, electrical ones and zeros. They are demultiplexed. The computer takes a little tag that says this is Granny, and it waits for another little piece of Granny and another little piece and adds them all together. And so it's got now digital ones and zeros that are only Granny, and then a digital to analog converter converts it back into analog, which her granddaughter hears. And this is done seamlessly back and forth with like a 99.999% confidence rate. I think all of us have had occasionally, though, you'll pick up the phone and you'll hear other people speaking and little like that. That's when the computer maybe is just a little bit off in its reading of the packets. The current deployed technology is 10 gigabits per second on one fiber. That's enough for 200,000 phone calls or 10,000 high-speed internet connections or 10,000 TV channels. So with this type of connectivity, you don't have to have many fibers, and something like a handful of fibers will handle most of the telephone calls between Europe and the United States. Well, scientists, even now, more than 10 years ago, continue to play with this in the lab. And since light doesn't interfere with itself, I can put a green and red piece of light together in the same fiber, and they won't know that each other is there. Now, it's not really red and green. The wavelength of the light is infrared, but they can put like 1.550 microns, 1.54. They can put about 80 such signals that are 40 gigabits per second, put it over fiber, and essentially separate it at the end. And so the capability of fiber from a physical, theoretical standpoint is very high. But, so let's go, we talk about how amazing all of this is, and there's one other thing on telephone calls. I know I look out at the faces here and I see a lot of youthful faces, but in the 70s, when I was just out of Cornell, if you got a telephone call, I was sitting in my office at IBM, I'd pick up the phone, and if I picked it up and I would hear, and then I hear some talking, I immediately knew it was a long-distance call. I put down the receiver. They wanted my office mate, who was from IBM Sweden, and he's working in the United States for a year. He was out in the lab. I'd run out and get him because it was costing $2 a minute. And I didn't even have to ask if it was long distance. I could tell by listening to it. So I remember when fiber optic became common across the sea in the late 80s, early 90s, it took me a while to get used to the fact that when you had a long distance call, it sounded the same as if it was next door, which most youngsters today would just take for granted. I am one of these people that some people tell me I'm assured that I will go to heaven. And the reason for that is I'm a subscriber to America Online. And the theory is that if you're an AOL subscriber, that you've suffered so much that God would always let you go to heaven. Well, one of the things that's interesting about this, and this is admittedly anecdotal, but it's, as far as I can remember, true. I've been a member since 1991. The largest file size I could send to somebody was 18.5 megabytes. What do you think the largest file is today that I can send? Same. 18.5. A presentation like this, if I wanted, I have a lot of images in this. this could be what you're seeing today because of the images. It's probably in the neighborhood of 20 megabytes. If I wanted to send it to my assistant, Shay, to make handouts, I have to put it on a memory stick and walk to her office. And I can't be the only buddy that's had that experience. Why are we standing for this? I mean, we should be doing something. I guess it's got to be an economics thing or something, but it just amazes me that we have no improvement over 20 years. Well, in preparation for this, and I don't want to pick on Mark Franklin, and I think most of you know this was a surprise talk for me. I only had a week to prepare and was scurrying around to try to get a lot of interesting information. So I just talked to Mark, and this is when our discussion together, but this is supported by some information I got a few years ago. If we draw a circle around Dartmouth, so this is us. Anybody have any idea what the bandwidth coming in and out of Dartmouth is? All of Dartmouth. Anybody know? According to Mark, and this is, I asked the question a couple years ago and got about the same answer. It's in the neighborhood of 1 gigabit per second. That's not 1 gigabyte, 1 gigabit per second is coming in and out of Dartmouth. That's not a lot. That's not a lot. And this is where I guess I need to be educated, because it seems that our connectivity rate is dramatically much lagging compared to the power of the individual tools that we have. And then it limits what we can do with them. Well, there are other people that claim this is true, at least in the United States. This was a survey in which they claim that if you look at other countries, Korea was the best. This is last year. This is a year old. Korea was the best in download speeds. Here we are in the United States, and this is upload speeds. And some people kind of commented that they were really surprised the land islands were so good. And am I the only one that don't know a lot about them? Maybe. But so, and this was something I was sharing with my class in Engines 1 last year. And so I went, you know, you can go on the internet, you can get on some website that'll measure my download rate with Comcast in Woodstock was this, 18.7 megabits per second, and my upload rate was 6.63. This is a year ago. So what do you think happened this year? Those folks at Comcast, they're doing everything for me. It's going to be 4 times faster, right? Half. It's half, just about exactly half. It was something like in the neighborhood of 9 and 3. So like I said, we're going backward as far as bandwidth. Well, this raises an interesting question. So this is Lily. Lily is a little over 3.5. She is my granddaughter. And her mother, she's very famous for something. I think I have enough time to tell this. She is the unofficial youngest person ever to attend a conference. When my daughter, who's a professor of statistical genetics at Harvard, was at a conference, Lily was just a couple months old, and my daughter was still nursing her, so she had to take her to the conference. And she went to go into the conference, and they stopped my daughter and said, you have to register the baby. And she said, you're kidding, right? So they actually made a name tag and everything. Lily had a name tag. Apparently it helped her because she was speaking in sentences at 8 months, so maybe that was a good thing. But anyway, what is Lily's bandwidth? This is an important question, I think. Does anybody have an idea? It's the same. I mean, obviously she's not any different than you and I. What's our bandwidth? So somebody like Ross, we want to know, what is he capable of soaking in? Anybody have an idea? This is from my friend Mike Littman at Princeton. So if this is wrong, you can blame him. The inventor of the Littman laser, by the way. He claims it's about 75 megabits per second. And the reason is, and he also told me that your brain spends 70% of its effort in supporting your sense of sight. 70%. That's how complex our sense of sight is. I think it's often overlooked by us. It's an extremely data-rich sense. And so most of that 75 megabits per second is in our sight, and a little bit, obviously, in auditory and maybe other things in like smell or whatever. So you then could argue, we have some folks in Vermont that want to do the Vermont Fiber Initiative. And the whole argument of this is to be with it, you should have fiber to your home. Well, typically, you would think if you were going to get fiber to your home that you would get with that 1 gigabit per second. Although you could have fiber delivered, and if you had somebody that wasn't delivering 1 gigabit per second, you wouldn't get it. You'd get less than that. But the point I make is, if somebody's going to give me fiber, I'm going to take it. But what I really want is bandwidth. Could somebody give me maybe even a real 25 megabits per second? Because pretty soon we're going to be regularly downloading movies, which are big files, and they take hours to download. And so I think the more important thing is to talk about some bandwidth threshold at which people should want to have, not so much will it be fiber. Because one of the things about fiber is it's great for long distances, but you don't really need it. If I had an electrical signal, I'm about almost 100 meters from my road. If I had an electrical signal at my road that was a gigabit per second, a copper coax cable could take it to me, and I could use that. It's when you get to be distances of a kilometer or so that fiber is really important. So I think people should be talking more about minimum bandwidth, something like 100 megabits per second as a target. Well, what about mobile phone data rates? Well, in the generation 1, we were just all analog, and then we went up to G2. That's when we got texting, and we could get the internet. And G3 was supposedly 1 megabit per second to 42. And I think if you believe these numbers, you're naive. That's what the networks are capable of doing. They're so overloaded that we seldom get what we're really paying for. And now we have folks like at AT&T and Verizon now arguing that they have G4. And I don't think these things have real crisp definitions, but they're talking about 100 megabit per second. I'd be kind of surprised if it's easy to really get that. In some respects, living in Vermont, I would just be happy if I could make a cell phone call from my home. But one of the amazing things about cellular phones, it's a device that is unequaled in history to how it's penetrated in the world. 22% of the lowest quarter of income people in the world. You take all the people in the world, you line them up, and you put them into quarters. The people that are the lowest quarter for their gross domestic product per person, then the next and the next. The bottom 25% of those people, still 22% of those folks have cell phones. These are people that probably aren't getting enough to eat, but they still have a cell phone. So the penetration is tremendous. And here are the number of cell phones subscribers in 2008 in China. You look down here. This is an interesting one to me. How many people live in Italy? Now, this is a little bit teasing. I don't want any Italians here to be offended, but my son, who lived in Italy for 3 years, explained this to me. A lot of the guys have one for their wife, and one for their first mistress, and one for their second mistress. I'm quoting. That's not right. Well, in a month's use, this is a year old, but still about right. In a month's use, if you have a feature phone, you're using 100 megabytes of data. That's in an entire month. You could download that on your computer here in minutes, right? If you have a smartphone, you get up to this. But this is what's really made the difference. What they're calling the super phones are really taking a lot more bandwidth. And it was, I think we're still in. And this is another perspective from some other folks that use about a gigabit a month if you do these sort of things, and you get up to gigabytes of data. This is not a data rate, this is a total amount. But the people who have the super phones are doing a lot of things like sending photos and watching videos and so forth, and they just take up a tremendously greater amount of bandwidth. And so this was the blessing and curse that AT&T went through, in that this is the amount of the traffic they got, and this is when here's the iPhone right here, and so it was, and they ended up having problems with their capacity. So I just in general trying to share, and I'm not an expert in this, I'm more an observer, but it seems though we really have both landline and mobile data width problems for the things that we want to do, especially when we want to start consistently downloading movies. Okay, there are a few things. So the point I've made so far is that electronic products have been a strong evolution, but the combination of them with cheaper memory and processing speed and the connectivity of the internet and wireless have created, admittedly, very much a revolution. There's a few things I've forgotten. I don't want to spend too much time on them, that are completely new things in a sense. The GPS system that President Reagan let other than the military use after the airliner was shot down, the Korean airliner was shot down because it got lost and the Russians shot it down. That's a new thing. And I would argue that an e-reader is a new thing. Now, I really fought this. This is my, this is my Kindle, because I really like books. But for reading, pleasure reading, it's pretty tough to beat. For textbooks, it's not that good. And one of the problems is it's not good on figures. And even if you're doing pleasure reading, like you're reading a science book by Stephen Hawking, it has a lot of figures in it, it's not too good. But I think that is something that's really here to stay. But one of the questions I asked as soon as the iPad came out, and I think I was wrong, is just how many things will we accept? I mean, when you go on a trip, you kind of accept the fact that you've got to take your laptop and your cell phone. And I said to myself, that's about it. People aren't going to take 3 or 4 things. They won't take their computer, a cell phone, and an iPad. Some people are, and they're taking their Kindle also. My wife has an iPad and a Kindle, and she really kind of prefers the Kindle for reading. I mean, you can read on an iPad, but it's not quite as convenient. One thing, the iPad being quite heavy. So I think it's still up in the air, but I'm kind of surprised that at least a number of people are willing to go to more devices. What are some of the other things that a blessing that some of us may have not connected to? Because of cell phones and computers, people worked their fannies off making batteries denser so that your cell phone could have a long period of time and have a very light battery. They really engineered that technology and put a lot of effort in it, just in time for Tesla to take, how many is it, 900 laptop batteries to power their car. And so a blessing, an additional blessing of the advances in electronics have been our advances in battery technology, which now makes, we're on the horizon of practical electrical cars. But there's one thing at least that I say we're regressing it. And it's probably because I'm a little different than the typical consumer, but the Palm Pilot. When I went and got this is less than a year ago, at the Verizon in West Leb, I said, so I got and everything, how do I connect so that I can sync my PC to the calendar and the book that has your people in it and all that, your contacts and all that? How can I do that? And they say, well, you connect to Google. And I said, I don't want to connect to Google. I want to connect to my computer. And they looked at me like I was coming from the Stone Age. You know, why don't you want to go to the cloud? Well, I kind of like to have it on my computer and not have to, maybe connect to the internet or whatever. And even though it's possible to do, what the Palm Pilot was, which was essentially had your calendar, it would had your contacts, but also they had programs that were kind of like a primitive Excel and even Word. And I'm not saying it's not possible to do that with this, but it's not the obvious thing. It's not an upfront function. You have to hunt around and buy it separately. And so what I first considered a smartphone, which was something that would handle my calendar and my contacts and do some Excel and all of that, is not impossible to get. But the main function of these today is really pretty much an entertainment device. And so we've kind of lost some of this. I'm not saying, again, you can get it if you want to, but it's not the main thrust. So, and I'm not done with this. Conclusion is, I see a strong evolution in products, but bandwidth is lagging for us to take the full advantage. It's kind of ridiculous that we can't download a movie at our house in, 50 seconds, I think, compared to the way everything else has improved. So, some people that study this think that the 20th century will be the century of electronics. Historians of science will look at that. Even though electronics is kind of my thing, I really think the 21st century will be considered the biotech or the healthcare or engineering and medicine century. And so combining the two with nanotechnology, I think, obviously electronics is still going to have amazing changes, but I think the things in biotech and nanotech will be amazing. And clearly electronics will merge with this. But also another thing that's very evident in the circles I travel is sustainable design. I know we talk about this here, but it's a real thing in the industry. It's really tough to have a company and not have a good reputation for sustainable design. It's some people will boycott your products if you don't do that. Okay, a little bit of thoughts in the future. Maybe I'll hold that for the last and just show you the teardown because the thoughts in the future may be a little more open-ended. So this is a teardown analysis of a droid, and so these folks, my friend, I should acknowledge him, Dave Carey, they buy things and tear them apart and talk about how they're made and so forth. And so when you tear apart a droid, it looks like this when you explode it. And lay everything out, looks like that. Then when you look at, this is where the battery goes. And these are the different microprocessors and memory and so forth. And the critical, this is the other side of the board. And you see they're putting integrated circuits on both sides of the board and so forth. But the critical metric they look for to see how well it's packaged, how dense you can get stuff in there, is the area of the silicon divided by the area of the device. And here, 82% of the amount of silicon that's in there is 82% the area of the device, which sounds very impressive. Well, for those of you that are, oh, and here's actually where you take one of the circuit boards and cross-section it. Manufacturing a circuit board like this with all these interconnected vias and everything is a very high value add skill. And sadly, this is one of the things that are legitimately concerned about in the United States is we don't do much of this anymore. It's done by a lot of companies in Taiwan. So this shows a very high density of a circuit board for packaging. But those of you that are iPhone fans can rejoice because this is a blow apart of the iPhone. And this is all of the, again, it's just mind-boggling when you see this all laid out, the different things that are in there. The packaging density is very high, but it's something that you could miss, is that they actually have two die here. There's one stacked on top of another. Now this isn't necessarily the die stacked on top of another die inside the package. It's likely a package stacked on a package. And I think there may even be one where they do three of this. But their density is just really, really the highest in the industry. And so right here, they have, if you take the area of all of the integrated circuits, it's 59% more than the area of the circuit board that it's laying on because of their stacking multiple dies. And as they say here, it's probably the highest in the industry. And I know a lot of people get excited about integrated circuits and all of that, but the accomplishments of a company like Apple, or I think the Droid is still a credible device, folks at Motorola, in packaging all of this in a tiny, tiny space and keeping it lightweight is literally a miracle of engineering. And some people tease that at one point the iPhone will be so dense that if you took one and dropped it in some water, there would be no air bubbles come out. Okay, the last thing I'd like to close with, I've got just a couple minutes. Thoughts on the future. This has been really an exciting couple of weeks because Watson, maybe I'll just talk about Watson first a little bit. Watson was on Jeopardy. I saw 2 of the 3 shows, and it was almost embarrassing for the humans. I think at the end, Watson had won about $77,000 and most of the humans about $20,000. But Watson did make a mistake. He thought Toronto was an American airport. And after thinking about it, I think I understand why, because Toronto is in North America. I don't think they said a U.S. airport. Maybe I'm wrong. Maybe they did say a U.S. airport, but he made that one mistake. But a lot has been made of this, and a lot of people getting excited, and it was much more impressive than I thought it would be because I give the Jeopardy people credit. The questions often were idiomatic and were written in English that was in some cases close to poetic, which is really hard for computers. Like instead of having a category capitals of countries, and then they'd have Sofia, and the answer would be Bulgaria, that would be easy for Watson. But they had questions that really had some plays on words. And yet, Watson did very well. Here is Watson. But one of the things that, so we can marvel at the creation, And some IBM folks were interviewed in this, and I thought they were very appropriately humble. Looking the best I can tell, having worked in IBM and whatever, they have stated that 20 of their research scientists at IBM Yorktown worked on this for 5 years. I estimate with ancillary contributions of support and everything that cost probably on the low side $20 million and on the high side $100 million. But it was worth it to them. It was a tremendous advertising feature that now maybe they can have intelligent systems that can assist surgeons and that sort of thing. But then the very next day, people were asking the question, could Watson pass the Turing test? The Turing test is a test where a person would sit at a terminal and they don't know whether they're communicating with a human or a computer. And they just ask free-flowing conversation. You know, like, what's your favorite sport? So I'm a golfer, I might ask Watson, do you like, or ask the question to either the person or the human, do you like golf? They say yes. So then I might ask some kind of subtle questions about Tiger Woods getting fined for spitting on a green 2 weeks ago, and, you know, try to make it so it has that aspect that computers have difficulty with, which is thinking sort of not with direct questions. You know, they do 2 + 2 is 4 well, but not subtle questions. So the conclusion from everybody that I've read, and after I got my sanity, after I was so psyched up about Watson, I thought maybe he could pass the Turing test. And people said no, even the IBM people. It was a $100 million, up to $100 million effort in a very focused way to help Watson, when you give him an answer, to ask a question. That's not anything like having a conversation with somebody and convincing them that they're human. And as one person even wrote in, and someone said the similar thing when the computer first beat a chess champion in 1997. For a computer to do something that requires algorithms is impressive, but when they can understand poetry and appreciate the beauty of a sunrise, then I'll be impressed. Well, in spite of all of this, the same thing, at the same time, this week, and I'm sure Time planned this, this came out just last week, right in time. It was in my mailbox the first day of Jeopardy with Watson. The man becoming immortal. And I'll try to wrap it up in a minute here. The leader of this belief is a guy named Ray Kurzweil, who's a very accomplished guy, a lot of inventions and everything. But he believes that by 2029, a robot will be able to pass the Turing test. And essentially the argument of this is the computation power, this is probably kind of hard to see, but the computation power of a human brain, they claim is, 10,000 trillion floating point operations per second. I don't know how they know a human brain is that many calculations. But here's where a computer is today, right here. And in so many years, the computer will be at that point, and then in so many more years, it'll be able to do more calculations per second than all humans that live. The thing I have trouble understanding in this, and maybe I'll leave you with this thought, maybe it's me, but we've made a lot of advances in calculation ability, but there's a lot more to being a human than just your ability to calculate. That whole idea of appreciating the beauty of a symphony, a sunrise, or a poem, or that very difficult question, is your best friend really just something that does computation, or is there something uniquely about your best friend that can't be described by the ability to compute, whatever? So, in interest of time, I guess I'll have to cut it short there. Do we have any time for questions or comments? Oh, okay. She was going to start laughing. Mark? Yeah.
Moore's laws of structuring something is kind of oddly, something odd about it, in the sense that it's a nice linear, at least linear on the log scale, continuous development. And yet, I suppose what it requires, like any of these linear patterns, requires a series of breakthroughs. Because you can never anticipate, it's not a trajectory that we could anticipate per se, other than in an empirical way. As you mentioned, you never would have anticipated breaking these barriers even a few years before those barriers were broken. Yeah. Is there any concept or kind of pattern to that series of breakthroughs? I mean, that's not just a...
Well, I think it's simple. It's what Michael Douglas said in the movie Wall Street: greed. I mean, you're doing it because you're Intel, you're competing with AMD, and I think it is interesting that it fits on the line so nicely, but I don't think there's necessarily a physical reason.
I guess what I'm asking is back to the title of the revolution, is that evolution is a series of small revolutions? Is that the case?
Yeah. In a sense, Mark's saying is the evolution a series of small revolutions? Absolutely. In making these integrated circuits, all the advances I show in making the line widths thinner, there have been regular revolutions that have been created in the physics of microprocessor design and manufacture. One thing I didn't get to say, by the way, the Ray Kurzweil thing. We had IBMers, 20, working $100 million worth of work to make Watson. Is there an equivalent effort to be making this machine that becomes a human? I mean, there is to make the computation power, but I think the software and whatever to do that is, would be a big project, and I don't know if anybody's working. Any other questions?
Any other questions from the audience?
Yes, of course.
One remark says how many electronic devices would you like to take on a trip?
Yep.
What I find most annoying are the charges we have to carry along.
Oh, yeah, right. Yeah.
Most of the time
You're right. Right. Yeah.
I think there would be some improvement if there would be one charger
Yeah.
for everything.
Yeah. Great.
Thank you very much.
Thank you. Yep.